Hey associates, this mini lecture expands on some of the technical visuals we are most likely to encounter when we experience, read, or create technical information. I'm going to discuss how diagrams, flowcharts, renderings, and tables tend to show up by walking through some real examples that I've found, collected, and come across in my life. First, let's recap on the importance of visuals at large and some of the tools people tend to use to create them. Visuals play a significant role in technical writing. Of course, most of the information is dense, or it could be abstract, or it could be important that people really see, understand, and can visualize, place, and position specific details and elements of the work we're trying to describe, show, or provide. We have loads of tools available to create these types of technical visuals. Some of them are simple with a really low learning curve and are wonderful for a little more simple of document types and content and information. Others are going to have a pretty high learning curve and may even have somebody specific on your team or your company assigned and trained to help you use those tools and create the assets you need. On that simple end, Microsoft Word has built-in visual tools that will accomplish a lot of the work you probably need done anytime it's a more simple document. Right from your content, you are able to insert tables and do quite a bit of customization to help it fit your needs. We can also insert flowcharts and simple diagrams using their Smart Graphic as well as their different shapes tools. And they have a great portal for importing and doing some light editing on visuals, photographs, renderings, that type of work. For most intro or simple or just kind of early quick ideas, this is going to be a great tool to get kind of that initial information down. Now, when your role, your job, or your product is up a level and that much more specialized, important, or finely detailed, you're going to have to turn to some of the more specialized tools for creating diagrams, schematics, drawings, and more. Companies like Autodesk create CAD and other design programs that allow you to make really specialized and detailed 2D and 3D drawings. But all of those tools and the level of complexity also comes with the price tag and the learning curve to match. There's also free options popping up all the time, FreeCAD, Schemit, just to name two of them, and they allow you to make the same types of schematics, drawings, usually in more of a 2D space that often get the job done, especially for student projects, or if your company, your workflow isn't requiring and needing really complicated renderings all the time. These programs usually come with pre-formatted assets for a lot of the mechanical and electrical engineering situations and diagrams that you would create. Usually you can also draw your own originals using basic shapes, lines, and sketching tools. And then we have the more creative programs like Adobe Express and Canva. I find these programs to be much better suited for annotating a photograph or working on a more simple process and flowchart rather than getting into specific lines and complex diagramming. And for those super specific situations where you need highly detailed 3D models or perhaps you need to animate different stages going on, you'll either need to get highly specialized equipment or even find the folks, hire out, bring in somebody on your team with that training, that background, and the skill set to make it for you. However, if you do want to start learning some of those, especially 3D modeling and rendering tools, Blender is a popular place to get started. Alright, so we're going to talk about the big four that we tend to come across both when creating technical writing, but more importantly, the big four that you're likely to encounter when you're reading technical information, and I'm going to react to some examples. We're going to go through examples of diagrams, flowcharts, renderings, and last, tables. Diagrams are graphical representations of concepts or processes. Common examples would be an architectural blueprint. It's a diagram of the building, but we can also think about them in terms of organizational charts, diagramming out all the people and the projects and the processes in your company. When creating diagrams, remember to keep them simple and clear. Now, simple in this case doesn't mean you're leaving out details and information and simplifying it. Simple means you're staying focused on the message and showing in the diagram the specific, direct, and focused thing that you need the people to understand. And make sure that you are using consistent symbols, colors, weights, lines, shapes when you're building it. Your company may have a style guide or expectation for what symbols, shapes, colors need to mean. Other times you'll have to figure that out for yourself, but be consistent within your documents, within your diagrams, so that way your readers can understand the pattern and quickly interpret your message. Flowcharts depict processes. Sometimes when you're trying to explain the steps of a process in words, it becomes really dense and hard to grasp. So a flowchart helps us see all the stages, how they connect. Flowcharts depict a process, usually with boxes representing stages and various arrows to show the sequence, flow, and progress of that process. To create an effective flowchart, you obviously need to make sure that all of your steps are accounted for and in the order that they need and have to flow. Then you want to use lots of arrows, boxes showing the direction, the connections, and any cycles that need to be repeated. Renderings are highly detailed and realistic depictions of something. So if you are making a product and you're not quite to the physical, tangible prototype stage yet, you probably want to make a rendering first so everybody can visualize what it's going to look like and start making some of those design details before we get to the manufacturing. You can also think of renderings as photographs of the objects, the places, the things that we're going to look at. Most commonly, renderings are associated with buildings because, well, you want to render out what your building looks like before you put in all the materials to actually build it. Effective renderings require good understanding of things like lighting, perspective, shadows, depth, because you want it to be as realistic, basically photoreal as possible. The key things here are to make sure that the person looking at your rendering understands and can really grasp and visualize things like the scale, the scope, and some of those fine details. And last, tables. Probably the simplest, but also most common, and in many ways most useful for the broadest amount of technical writing. Tables represent a structured set of data or information, and we put it in rows and columns. They usually represent numbers because numerical information, when read or formatted as a paragraph, is the actual worst thing to encounter, but we can also put qualitative information in a table as well. The big thing for the table is making sure that your rows and your columns have real meaning and connection. The rows need to represent clear and consistent categories, so we see that pattern across, as well as your columns representing that consistent pattern of information associated with the corresponding row. Let's check out an example. First, I do need a beverage cooler. We are in the process of renovating our kitchen right now. We are going to build like an island with a bar situation in it. And so one thing that we really want is, a nice small beverage cooler. So it needs to, be able to fit underneath the counter, kind of in the space. And we're in that stage, right, of mapping out the floor plan and seeing the options. So I've hopped into like the Home Depot website, not sponsored, but I've spent a lot of money there. So I just searched up right drink coolers, and right away on the page, I see lots of photos, right? So these are photos. Some of them might be, realistic renderings, but probably most of them are product photos. I would imagine, though, it is definitely in the realm of likelihood that some of these beverages that are on the inside at the very least are, renderings, and they didn't actually stock any of these fridges with actual products, and so they just, inserted some things into it. Like, I don't understand what's going on, like, in this, the idea of scale, right, is not very clear here. They have it next to this table, and based on the scale that they chose, it makes it seem like this fridge is, bigger than the average table, even taller than the countertops, and, takes up quite a bit of space. This one, definitely much clearer scale, having it rendered inside of a countertop, like this is what we'd be looking for more, but this is a really poor example that does not clarify, actually introduces way more confusion right into the process. And then example of a table right here, right over dimensions.
It's sort of a quasi table because the rows don't like fully kind of translate sort of to the columns, but we have the width and then easy to see how wide, depth, all of the key dimensions that should correspond with the visual. And so you can imagine, right, if all these details are just written as a paragraph. Yeah, that is awful, right? That is awful to imagine and visualize. So I'm definitely glad that they chose to do it in this very visual format for all of the numbers that we, were seeing and that we had. All right, now I am looking at the org charts for my campus organization. And so org charts are definitely a helpful way to sort of visualize and show people the relationships within a company. And so maybe if you start your own like startup or business, you'd want to create an org chart like this to keep track of everything whenever you maybe are applying or interviewing or get hired in a job or even like your current job. It can be definitely useful to find your company's org chart just so you know who all the key players, stakeholders, and the new system, right, that you exist within. And I actually have not looked up the full org chart since starting this job, so let's kind of take a look. Boxes and lines, that's kind of what you get with an org chart or any kind of flow chart process diagram. Lots of boxes, lots of lines showing the direction. And so the college deans, so my boss's boss, basically, right? College Letters, Arts, and Sciences, going to be Dean Vidler. They are right over everyone in the college that I work in. And then Dean Vidler sort of is lateral. So these are kind of all the same level, sort of colleagues of them for all the different, here's our College of Engineering Applied Sciences. Interim, right, means they are hiring a new one. So you probably saw emails about that, I guess. Cool. Then if you go up this line, the college deans report directly to our provost. So that's what that line signifies. Okay, so then, right, this provost, right, same level as this provost, kind of as this one. This one's all focused on research. And then these are all the people that sort of report to the chancellor for research. Right? This one is the vice chancellor for academic planning. We see our Excel centers report to that person. Dr. Marshawn Mortella, the provost, reports with this little direct line to our actual chancellor, who then reports to the entire university system president, who that person even has bosses, and that's going to be the board of regents. That's kind of interesting. I learned something. All right, the last kind of example I just wanted to walk through that has, these different things, actually is this full program plan and report that was written in 2020. Yay! All right, let's go through. This seems more like an actual photo, just because, one, people are very, very, very hard and expensive to render. In fact, a lot of things will not even attempt it because they always look real wonky. So if you have people in the rendering, that's a pretty good chance it's probably a photo itself. Yeah, there's so many details, stuff in the background. I just don't really think that they would have rendered that out. Nice little summary, love that. Oh, we got a table. Okay, here's how big it's going to be, timing, money endowment. Okay, cool. Now, one thing that's kind of interesting about this table, again, it's works visually, but is technically not really, I guess, right, as a table.
The rows need to represent clear and consistent categories, so we see that pattern across, as well as your columns representing that consistent pattern of information associated with the corresponding row.
Just because usually, right, when we see a table, right, it's more like this. Everything labeled in this row sort of relates to each other, in this column, relates to each other. So that way, when you look across the row, you can see that consistent, information. And here, since it has two rows, but the second row, doesn't actually create a category that all of the columns fall into, right? It's just saying, hey, this is going to be 24,000 square feet. And then here's the timing, but it's not timing for each like square foot or anything like that. So, like from a human processing standpoint, it's pretty easy to understand what they mean by this kind of like table-esque visual, but it also has the potential to introduce a little confusion because it is co-opting kind of the design of a table without truly leveraging what tables are made for. Whereas this one, again, it's a much more direct comparison within the row. Start date, completion date for design, construction, right? Occupancy, all that stuff. All super blurry and kind of low quality. So honestly, I don't know what or why it would necessarily be included. It doesn't give us a really good idea either way. Prototyping, cool. Justification. Okay. Goals, table without the lines. That's, fine too, as long as we can easily track, offices, columns. You don't always need the lines, but that it is so small definitely makes that easier to see. Okay, again, mix of photos. I really can't tell. I don't know. Like, maybe they like morphed or merged some like old photos together. I honestly don't know, because it seems like logically it seems like this should be a rendering of what the space will look like when it's done, and it like has some kind of that weird almost like too glossy sort of high sheen quality that a lot of photorealistic renderings get. But then again, we have like these blurry people. Ooh, space requirement. Okay, here's a proper table. Space ID, so everything in this column indicates a space. Everything in this column, right, is its corresponding type. What are we going to call it? Occupancy count, right? Every column lines up. So when you look across the row, you get that same consistent information and categories every single time. And again, imagine this as a paragraph. Trying to find, what space, conference room, 1.13, its size. Like, if you had to read through a paragraph of that, it would be an absolute nightmare. Ooh, here's a map. Just another just jelly type of visual, kind of going in that it's not really, it's kind of like a diagram, but also it's just a map. Just know sometimes it's good to put maps in your technical stuff. But then I love this, right? They have a nice aerial footage with some annotations to show where this thing is going to be located. So that's pretty cool, actually. Yeah, a little campus. Okay. 6 components. Here's another kind of little diagram of a floor plan. Architecture uses a lot of diagrams because it's hard to describe in words what a building's like footprint is going to look like. They do describe it in words as well, but it's definitely easier to understand what's being described when you can like visualize the floor plan, stairs, doors, all of that in there. Shops, classrooms, cool. Okay, a little side view diagram to get some of these sort of heights and measurements in the design. Well, they also talk about, what it's going to look like. And so we kind of see that, right, reflected in the design as well. Cool. And here's our conceptual building rendering, right? So you can see it's like a true rendering, right? The people aren't like really people-y, right? That's kind of artistic in those elements, but you do get a really good sense of what it will look like and what it could look like. They basically made this, right? You make a rendering, so you can basically make the thing. Cool. All right, that's pretty fun.
Understanding how to create effective visuals is of course important for writers, but the bigger thing to me is understanding how to interpret these visuals as a user, consumer, and reader of technical content. Diagrams, renderings, flowcharts, and tables all have specific purposes and are most appropriate in different information situations. It's good to know that when you come across a rendering, you understand what it is you're looking at. Same with a table or how to read the diagram. By practicing techniques for creating your own technical information in a visual way absolutely will help you be a stronger technical writing consumer and get your job done, find the information you need, and understand what it is people are trying to tell you more quickly. Fun time looking through these examples. Thanks, associates. Vibes.